Imagine that you open your phone and all your data, photos, and videos are stored in space. While this may seem like a distant future at first glance, companies like Google and many research teams are already working on this technology today. They are heading towards one ambitious goal, which is to build the first large computing clusters directly in space. At a time when data centers on Earth are hitting limits of energy, water, and space, this idea is no longer pure science fiction. The question arises, could space offer an environment paradoxically better suited for computations than the planet we inhabit? Does this even make sense? What advantages do space data centers bring? And could their future truly be more beneficial than operating servers here on Earth? All this and much more you'll discover in today's episode. Data centers in space mean a big change in how we think about performance, energy, and cooling. On Earth, servers consume huge amounts of electricity and require complex cooling with water or air. In some regions, this causes water shortages, overburdened power grids, and local opposition to another concrete facility outside town. The digital world is simply starting to hit the planet's physical limits. The idea of moving data centers into space has a simple justification. In space, sunlight hits satellites almost constantly, and no one will argue with you about the consumption of thousands of liters of water for cooling. You don't need cooling towers or complicated infrastructure around them because you can dissipate waste heat directly into cold space. Theoretically, you can keep the servers at their operating temperature, so another power plant doesn't have to be built nearby. It sounds great. Reality, however, is far more complicated. Radiation, vacuum, extreme temperature changes, micrometeoroids, and most importantly, transporting the hardware itself into orbit. All these are problems we must solve before StarCloud becomes a common part of the internet. StarCloud, a company that's been much talked about recently, has already managed to launch a prototype satellite equipped with an NVIDIA H100 computing card. This is the very same GPU that we use for demanding computations or for training artificial intelligence. This marks a historical step because up until now, primarily smaller, modified onboard computers have been utilized in space. StarCloud aims to deploy fully fledged modern hardware in their stead and then monitor its performance under actual space conditions. Simultaneously, it conducts tests on thermal, radiation, and power supply systems, accumulating valuable experience for upcoming clusters, generating tens of megawatts, which would be entirely powered by solar radiation and cooled by the vacuum of space itself. Google is considering a similar approach with its Suncatcher project. It envisions the deployment of dozens of satellites in low Earth orbit at about 400 kilometers above Earth to maximize their access to solar energy. Google is betting that the cost of launching cargo into space will continue to fall thanks to reusable rockets, and that operating a cosmic data center could, within decades, be comparable in cost to a giant server farm on Earth. However, skeptics argue that while images of space servers look beautiful, physics is unforgiving. Paradoxically, one of the main problems is cooling. Space is extremely cold, but in a vacuum, you have no air or water to dissipate the heat. The only option is to let the heat dissipate using large radiators. These add significant weight and surface area, and they need to be carefully folded into the rocket, then deployed once in orbit. For processors and GPUs that consume hundreds of watts, this presents an even greater challenge than what we face in a traditional server room. Sponsor of this channel is Buddy, your mentor and AI friend. Just enter Buddy FM and you can try it for free. A significant challenge that we face is the harsh radiation environment. Up in orbit, electronic components are constantly exposed to cosmic radiation and charged particles, which can lead to errors or even total system failures. But for servers located in an air-conditioned data hall, nothing will damage your memory chip just because a single charged particle flew by. But in space, this is a reality. Therefore, space data centers will require special shielding, intelligent backup, and software that can detect and fix errors without the entire system failing. Communication is also crucial. Most demanding tasks require very fast connectivity. Otherwise, a space data center would just become a luxurious warehouse. The solution is laser connections, so-called optical links, which can transmit data faster and with less latency than traditional radio waves. But even here, we encounter limits. A light beam needs a clear path, and adverse weather can complicate communication. Therefore, a combination of multiple satellites, ground stations, and intelligent data routing is being considered. However, space data centers won't be suitable for absolutely everything. It's excellent for massive AI training, for processing satellite images, or for generating large models where a few dozen milliseconds of delay are fine. However, it's clear that with the rising demand for AI, blockchain, or simply the massive need for cloud, finding new ways is unavoidable. World's data centers already consume about 2% of Earth's electricity, and this number is set to increase even more over the next 5 to 10 years. Therefore, a model where we shift some of the data burden to orbit might prove beneficial in the future. Some visionaries even envision structures of a far greater magnitude than mere dozens of satellites. Sam Altman from OpenAI has mentioned that we might one day construct vast solar systems in orbit, like colossal Dyson rings. These are enormous spheres around the sun, which would serve purely for computational purposes. While still pure sci-fi, this vision hints at a trend. The space around our planet and the sun could offer nearly limitless solar energy. Whether you're skeptical or fascinated by a giant space cloud, it's clear projects like StarCloud or Google Suncatcher are opening a new chapter in computing infrastructure. Let us know what your thoughts are on data centers in space. Is it a crazy risk or a logical step towards a more sustainable future for our digital civilization? If you enjoyed this topic, don't forget to hit like and subscribe so you won't miss any news from the world of technology. Have a great one, and we'll see you soon in the next episode.